Okay, let's go back and start talking about some normal distribution, all right? So we're going to be looking at our properties in this first section, kind of getting our feet underneath us a little bit. So let's jump right in. Imagine that a friend of yours is always late. I know a couple, I may be that couple. Friends like that every once in a while. Let the random variable x represent the time when you're supposed to meet until they show up. Suppose your friend could be on time, so x equals 0, that means on time, or up to 30 minutes late. All right, so that's what it's saying. So on time means 0, and then it starts counting with how many minutes late. That's what our grid is about. With all the intervals equal time between 0 and 30 being equally likely. For example, your friend just as equally likely to be 3 to 4 minutes late as he is to be 25 to 26 minutes late. So the random variable can be any value in the interval between 0 and 30. So between 0 and 30 inclusive. Because any two intervals between 0 and 30 inclusive are equally likely, this is said to be a uniform probability distribution. So if it's uniform, if everything is equally likely, there is no difference with any of this, it is all equally likely, that's what makes this uniform. All right. And notice it looks like a box. It's uniform of what you have. Here's the deal. This is a probability, right, that we're looking at here. So the area always has to equal 1. So when I'm looking at this, I'm going from 0 to 30. This is set as 1/30th because this is the value to make the area equal 1. So in order to make my area equal 1, I have to put my density up here at 1/30th. So every single minute is what we're looking at. So the first minute is 1/30th because that's 1/30th of the total breakdowns here. That's each one set up as 30 minutes. You get that? So 30 minutes total, each one set up for 1 minute to make up that 30 minutes total. That's what we're talking about. Okay, that's how this value came into play because of that. Okay, that's a uniform probability distribution. That's all there is to it, right? So a probability density function is an equation used to compute the probabilities of continuous random variables, and it must satisfy these two conditions. The total area under the graph over all possible values must equal 1. That's where this came from, right? The height of the graph must be greater than or equal to 0. It doesn't have to go up very high, right? This is 1/30th. So, I mean, this looks like a big rectangle, but it's not, right? Like if you were saying, oh, 1/30th, depending on what your units are, that's how big it looks. 1/30th is a really small fraction, but it's all consistent. And that's the whole concept that's going here. Probability density function. All right? And that's where this word density also comes into play for us. Okay, so refer to this example. So your late friend is what we're referring to. What is the probability your friend will be between 10 and 20 minutes late? So they already have this set up for us as the green rectangle. So what we're trying to figure out is the area of the green rectangle. Or like this piece in between the 10 and 20 minutes, right? So if I'm looking at the rectangle, what's the area of a rectangle? How do you find that? Length times width, right? Okay, well, what is my length here? How tall is my rectangle? It's 1/30th because that's what they all are. So what is the width of my rectangle? 10, right? Because it's between 10 and 20. So if I'm going to find this area, this is going to be length times width. And that's how I have 1/30th times 10. So if you have 1/30th times 10, right? This is over 1. 10 goes into 33 times. So my area here is 1/3, or if you're doing it in your calculator, you'll get that 0.3 repeating. Okay. So that's my probability. The probability that my friend is going to be 10 minutes late is 0.33. That's my probability. All right. So let's make another way to figure this out. So it's 10 a.m. So let's put some time to this. Instead of just generic minutes late, let's put a time to this. There is a 20% probability your friend will arrive in the next how many minutes? So this 20% probability right here means that my area, so the area that we're looking for is also set up as that probability. That's my area, right? Full probability means my area will equal 1. That's like saying that I'm looking at this at 100% up here. Down here, my question specifically says 20%. So I know the probability. I'm told the probability. The probability and the area, they're talking about that same thing. So if this is a rectangle, I know that the probability is equal to my minutes times my density, because that is still my length times my width, right? Those are the values that we're looking at. So I know my probability, which is my area here, is 0.2. My minutes goes from 0 to x naught, it's called, because it's at sub-zero. So that's how many minutes. That's what we're trying to figure out. I don't know how many minutes. That's my variable. That's my unknown. But my density here is still 1/30th because that's how tall my rectangle is. Now, how do I get rid of a fraction? Right? So we have this fraction, my minutes times this fraction. How do I get rid of that fraction? Because my goal is to get the minutes by itself. Yeah, so you multiply by the reciprocal, right? So I'm going to multiply here by 30 over 1. This is times 30, or 30 over 1. Those cancel, and I'm left with x is equal to, what is 30 times 0.2? 6. So there's a 20% probability your friend will arrive in the next 6 minutes. It's just rectangles. When I'm looking at this uniform density, I'm just looking at the rectangles. All right? Pretty cool.